Good morning, class.
Morning.
Yeah, welcome for today's class. So maybe I can just ensure that you are well spaced so that I can freely walk through the room. Yeah, it's very much okay. So maybe if you just confirm that the windows are open so that you can have some fresh air. You don't want to be sitting in a stuffy room. Yeah, that is nice. So I'll just call the class registrar. So Michael,
Present.
Don,
Present.
Juliet,
Present.
Brown, present. Bramwell,
Present.
Oscar,
Present.
Bethel,
Present.
Damaris,
Present.
Mary.
Present.
Yes, so I can see all of you are in. So when we met last week, we finalized on the topic logic gates. So I just want at least 6 of you, at least to name each one logic gate that you can remember. Yes?
And not gate.
And not gate,
And gate.
and gate,
X or gate.
X or gate,
Not gate.
NAND gate,
Or gate.
or gate. I guess you have exhausted all of them. So I just want to focus only on 2 because at least each gate has its own truth table, right? So I won't necessarily want you to draw for me the truth table. I just want you to give the brief description of what the gate does. So I'll just focus on the AND gate and the OR gate. So maybe someone can explain to us what basically an AND gate does. An AND gate. Yes?
It is a type of gate that gives an output when all the inputs are on.
Yeah, she's basically correct. So for AND gate, all the inputs have to be high for you to get a high output. And then maybe the last one, an OR gate. Any one of you who can remember what we said about an OR gate? Yes?
Is an gate that gives an high output when either one of the inputs is high.
Yeah, correct. So for an OR gate, at least either of the inputs has to be high, or all of them have to be high. So when either of the input or all of them are high, the output will be high. So for today, I want us to introduce a new topic. So what is the date today? 18th. So our topic for today will be introduction to microcontroller circuits. So that will be the topic for today, not circuits, it's technology. So introduction to microcontroller technology. So and by the end of the class, we have some 3 outcomes that I want us to have achieved. So the very first one is to explain the applications and as well as the characteristics of microcontrollers. The second objective is to explain the different elements of the microcontroller. And then the very last one is to describe the various microcontroller series. Describe the various microcontroller series. So at least by the end of the class, we are supposed to have achieved these three outcomes. So I want to start with the very first one, the applications and the characteristics of microcontrollers. So I'll begin with the characteristics. But before we start, I don't know if you are conversant with the term microcontrollers, or have you ever encountered a microcontroller? A microcontroller. Have you ever heard of that word before?
Yes.
Yeah. So basically, microcontrollers, they are circuits or simple IC circuits that contains all the components a computer has, but they are supposed to achieve a particular task. So you see the way a computer is, which has the monitor, the CPU, the keyboard, everything. So that computer, it has been integrated into a very small IC. So the whole computer is integrated into a very small IC, and that IC is dedicated to perform only a particular task. So I can just basically draw here a rough image of maybe what a microcontroller can be looking like. So it can come maybe in such a shape, or others can come in those shapes. So I'm so much sure in your electronics practicals, you have encountered either of these two ICs, and they usually come with a brief description or name of the particular IC on top. So when you see this over here, some of them are called microcontrollers, and they perform particular tasks. So we want now to look at the various characteristics. So the very first one, they consume low power. So because they are basically small integrated circuits, and I'm so much sure in your electronics labs, you have always been using 5-volt DC power supply when feeding these kinds of circuits. So you can imagine the normal computer, it sure uses the normal 240 volts supplied by the sockets. But for this one over here, it will now be using the normal 5-volt DC power supply in the lab. So they consume a low power. Apart from that, they are compact and cost effective. So a whole computer, it can cost up to even 70,000, 80,000 and so much like that. But when you come to these microcontrollers, they are so cheap. You can find that one IC, it can go even to as cheap as 400 or even 300 shillings. So that is why they are being called cost effective. They come at very low prices. The next one, they operate in real time. So for these ICs to work, you have to connect them and power them in real time. They cannot work on their own. You have to power them and to give them the program so that they can work as expected. And then the very last one, they are designed for dedicated tasks. So we know that a computer can perform different kinds of tasks. You can do maybe if it's the normal writing in Word, if you want to do calculations using the calculators, if you want to do the video conferencing. So for computers, you can perform a variety of tasks. But when you come to the microcontroller, each microcontroller is designed for a specific purpose. An example, maybe if you're using a particular microcontroller to control maybe like the lights, it will only work for those lights. If you pick that microcontroller and put it maybe like in a washing machine, it will not function because it has only been programmed to perform that specific task. Or maybe if you take maybe like a microcontroller that is working in a clock, the digital clocks, and then you put it in a washing machine, they might be having the same structure physically, but they will not be maybe doing the same tasks. So each microcontroller performs its own specific task. So that is that on the different characteristics of microcontrollers. We have said that they consume the low power, they are cost effective, they operate in real time, and they are also dedicated for particular tasks. So that is under the characteristics. So I want us to address the applications. So I want to get the responses from you because at least we have been interacting with these microcontrollers in our day-to-day lives. From when you were a small kid up to now, I'm sure at least in your day-to-day activities, you have been interacting with microcontrollers. So I just want to get some responses from you on the different applications of the microcontrollers. So I can welcome the responses from you guys. Areas that you feel microcontrollers are used.
Okay, they are used in the home appliances, especially in microwaves.
Okay, so the very first one, home appliances, right? And just given an example of a microwave. I've also talked about the washing machine, right? So a microwave, we know basically it can be used to heat food or maybe defrost food, right? So a washing machine, we know that it's basically used to wash clothes. You cannot be able to use a microwave to wash clothes, right? And as well, you cannot be able to use a washing machine to warm food. You can be able to see that each microcontroller performs a given specific task. You cannot be able to multitask them. Maybe another application.
Used in communication devices like modems, routers.
Yeah. So they're also used in communication devices, right? He has given an example of a router and a modem, right? So we know that these two, their major task is basically to transmit maybe the bandwidth so that at least different areas can be able to access internet. So those microcontrollers that are specifically used for communication, you cannot be able to use them to perform different activities. They're basically suited for those communication devices. So that is another application. Any other?
Can be used in industrial organizations, let's say programming, automations.
Yeah, very much correct. So he has talked about industrial setups, right? He has talked about automation and as well as programming. So I'm so much sure that all of you, at least in your experiences, you have ever maybe visited an industrial setup, right? So when you walk into an industry, you will see that there are different machines specifically set up in different places. You can be able to see maybe certain machines can be maybe putting the bottle tops on the bottles. You can be able to see conveyor belts moving goods from one place to another. So each particular machine has its own program that controls it. And that program is being controlled by the microcontroller. So in an industry, you can find that there are different sectors with different machines, and all those machines are being controlled by independent microcontrollers. Any other application? There are so many, so I can just welcome one more.
Security systems.
Yes, security systems, maybe you can just explain.
In the security system, they're used for alarms and access control.
Yeah. So security systems. He has talked about alarms and access controls. Yeah, so we know that in most of these maybe institutions or maybe the private residences, some people have been able to implement security features so that when you want maybe like to intrude the premises, there are alarms that can be sounded so that they can notify the owner someone is intruding into their spaces. So those kinds of controllers can only be used specifically for those kinds of setups. So there are still many more applications that you can list, but at least I just wanted us to have an overview of the few that you have discussed upon. So that is that with our first objective. So we can go to the second one, explaining the different elements of the microcontroller. So I can just briefly write it down here. Elements of a microcontroller. So we have said that a microcontroller basically is like a huge computer has been put into a small chip, right? A huge computer has been put into a small chip. So one of the elements, we have CPU. The next one, I'll list them. We have RAM, we have ROM, stock EEPROM, we have input stock output ports, and then we have timers stroke counters. So maybe because of time, we'll just roughly rush through them. CPU. I know you know the full meaning of CPU. Maybe someone can just tell us the full meaning of CPU. Yes, Central Processing Unit. So a CPU, it contains the program that runs the entire microcontroller. And then RAM,
Random access memory.
random access memory. So this one here, it is always said to be volatile, and it is always easily accessible when the microcontroller or the operation is being done. We have ROM. Maybe you can give us the full meaning of ROM?
Read-only memory.
Yeah, it is a read-only memory, and it's always permanently constructed. You cannot be able to erase it, right? It can only be read from. And then we have this other one, EEPROM. So EEPROM, it stands for electrically erasable programmable read-only memory. So this kind of a ROM, it can be erased electrically. So ROM cannot be erased, but when you have this other type called EEPROM, it can be erased electrically. And then you have input stock output ports. So this one over here, it allows you to connect your microcontroller to various input devices and output devices. And then the last one, timers and counters. So this one here, they will enable you to maybe time your particular microcontroller or give it a particular count. So I guess that is that for our today's class. So for the assignment, if you access your course in the LMS, the topic for Microcontroller Technology, I've put there a discussion forum. You'll be able to access it, and then you'll find the questions that I've embedded there. So the deadline is supposed to be on Saturday. So once the deadline ends, you'll not be able to access the discussion forum. So just ensure that you access it by Saturday. So have a wonderful day.